So, welcome everybody. My name is Pim. I'm a consultant with JDriven, typically hired by organizations to fulfill the role as a solution architect, basically analyzing their needs and come up with a matching solution. Uh, was the case for the Dutch Railways, basically Dutch Railway Company and ProRail, NS and ProRail. And on this job, I come across Apache Ignite, which I really liked upfront because it's such a versatile product which you can actually use for various applications, and it was a really nice fit for the project I'm going to tell about today. Having introduced myself, I would like also to have a little introductions of you people. And in doing so, when I ask you whether you've experienced uh, the public transport in the Netherlands, uh, either respond by nothing if you're in a noisy environment, or no if you're from the Netherlands, or yay if you actually have been in the public transport in the Netherlands. So when I ask you, have you ever experienced the public transport in the Netherlands, please let me know.
Yeah.
Yeah, I would do.
Oh, I was already a little bit afraid you'll all be in the same building. But yeah, let me talk a bit about this project I did. This was a bit of a year ago, and let me tell you a little bit about the Dutch infrastructure. As you can see, this is a map of the Netherlands, and with the red lines, you see all the rail infrastructure that is in the Netherlands. Which is quite a lot. It's a very dense track, very occupied. It's almost even more than 7,000 kilometers of track, and every month about 14 million kilometers are driven on that track by the trains. There's approximately 400 stations. You see this little URL. This shows you a really nice map of all the stations, like for instance, it would be a metro station or a metro network. These over 7,000 kilometers of rail track includes 6,000 rail switches, which have to be operated, quite some signals, over 12,000, and 70 bridges, which can actually move. So these are train bridges where trains run over, and these bridges can be opened. The Dutch railway infrastructure is like the third most occupied rail infrastructure in the world. Switzerland and Japan are also very occupied rail infrastructures. And if you have a look, I don't know if you know the map of the Netherlands, but close to Amsterdam, we have the Schiphol Airport, which is like the busiest piece of track now that we know. And each hour, 15 trains travel on that little piece of track. So it's pretty occupied. You can imagine if one train would be a few minutes slow, this could affect all trains traveling in that region. And what is very interesting in the Netherlands, compared to other railway operators, is that it has an open structure. I mean, every company, every railway company can actually run their trains on the Dutch railway infrastructure. It's like an open planning model. So the job I had to do was a solution architecture at the planning system, which was for all the planners in the Netherlands who operate on the rails. Now, this granting whether or not you are allowed to travel on those rails is managed by ProRail. ProRail is the company that maintains and operates the rail infrastructure in the Netherlands, while NS, with the little logo, yeah, that one, is the biggest operator on the rails, moving people around. Quite a lot of them. And so every traveling company that travels either cargo or people on the rails can plan on this software that is developed in a cooperation between the Dutch Railways and ProRail. This is sorry. This is like the open model, and the service provided in this cooperation is like planning as a service, which is quite a huge system. It's been around for 15 years. Before that time, the Dutch Railways had their own system, but due to European regulations, uh, everybody should have a fair chance to operate on Dutch Railways, and as such, this planning system was developed. Now, how does this planning work? I would like to explain this a little bit such that you know what challenge Ignite was up to. And let me first show you a coarse-grained model of how the planning is done on the railways. Oh, wait a minute, got a nice picture for that one. At the top, you see the planners, which could actually be the operators which move people around. Could also be ProRail itself doing maintenance. Um, they can plan like 2 years in advance or a month in advance and getting more detailed at day level. They can plan in the system, put in their movements, which is about 10,000 movements a day, which is currently being planned. And if an operator thinks, yeah, this is what I want to do on rail infrastructure, they can submit it in the system, and then ProRail has operators who actually check whether this planning they created is safe and operable. Now, there are a lot of checks there really supporting the planners because the operating on the Dutch railways planning is not really easy. Even in order to do so, to become a planner, you have to have an education and an exam. And if you pass it, you are allowed to plan on the Dutch railways. And if the operator grants your plan to be operable and safe, combined with all the other movements that are planned, then it's granted. And this is actually the final product of this planning system, an operable and safe plan for execution. Now, what is the challenge? Uh, we have like a very dense network, and we like to run more trains every day. I mean, the public transport in the Netherlands is so really popular next to bikes. It's an increasing demand of rail infra capacity. Uh, it is even as such it's such popular that for years or even decades we had a little bit of an issue with all the bikes parked at the train station, and so ProRail and NS even created bike parking centers at every station, together and competing with each city who has the biggest bike parking in the world. Currently, that will be Utrecht, which can hold 22,000 bikes at the station. By the way, if you have some questions, please don't hesitate. Just ask them straight away, and I'll see if I can answer them. Another thing that we would like to accomplish in this planning is energy efficient traveling. I mean, current and the environment is an ongoing topic. And of course, you can try and get the train as fast as you can from A to B, but you can also do this in a very energy efficient manner, not accelerating too much and not braking too much. So this was a long-term goal, which one would like to try and achieve in the planning, although it makes it a bit harder in the planning because if you do energy efficient traveling, this also means you're going to occupy the rails a bit longer. And another challenge was long-term planning, and that's typically plans 2 years ahead. So 2 years, this is a lot of data. First, try starting with patterns. So the planners, the planners first put in some patterns, like this train is going to operate 10 minutes past, and 20 minutes past, and maybe a half past. And once you get closer to the execution date, they fine grain this planning, like this is only during rush hour, or this is only in the weekends, these kinds of things. And this was this is the way they make the planning, and this is a huge amount of data. And of course, when all these planners, like 400 people, put in their demand, this can be conflicting. And it's really hard, for instance, operating the switches. It's really hard to get all these trains moving around the country without creating hazardous situations. So we have a lot of checks you see in the middle, just to support the planner that if he plans something that's not going to be operable or it's going to lead to any unsafe situation, they get a notification and they can correct it accordingly. But now these are checks like, for instance, did I leave a wagon somewhere, which is obfuscating the other stuff. But this also means isn't the train driving close to another train? Now there were already some signaling algorithms in the planning system that was already there. Although this was really coarse-grained, really focusing on the areas where train stations are and which are controlled from control rooms, which I will show later on. But let me get a bit of water first.
Can we try to do something with microphone, because it's cracking a bit more than while sound check?
Oh, I'll try to keep my voice a bit down. Is that better?
It looks like that. Thanks.
Yeah, maybe I'm a bit thrilled about you guys. I try to keep the volume a bit low, my natural language. But we wanted to have a better algorithm to have to assure the safety in the plan. Now, if you look at the rail system, there is already a safety system in place. Let me show you that. For instance, if you're inside the cockpit of a train, you get signals like traveling signals, traffic lights. Although on the rail it's a little bit different. You have travel lights which tell you actually if you can drive this piece of track. If it's red, you can't drive it. If you actually decide to drive it, the power will be removed from the network and the train will stop. Now, if you want to have a safe and operable plan, avoiding these kinds of situations, we actually try to simulate, or actually what the domain specialist told us, let's simulate where each train will be on the track at any given point in time. So of all these plannings we have, like 10,000 movements a day, let's plot it on the rail infrastructure and see if trains are close to one another, whether they're not going to run through red signals, or basically we even have like a green wave of signals that you can actually keep on driving, not having to stop, the energy efficient part. And so in the planning, if you want to have a really safe and operable plan, it's wise to honor these planning rules. But this was basically the target or the challenge we put up with Ignite. I selected Ignite because from IT point of view, if you have like 10,000 movements a day, this is a lot of data, especially if you're going to very fine-grain simulate where each train will be. And if you want to know if there's an overlap between these trains, these are a lot of comparisons. Let me show a little bit of the process for that. So we picked Ignite because Ignite offers a computational grid, which allows us to, on one hand, with the data grid, store all the data we derive from the planning. And on the other hand, it provides the computational grid to actually derive information from it. Now, how did we design this? If you look at the 1 o'clock that's where everything starts. They're like every time a plan, for instance, for the next year or for the next few months, this is created in a plan. It's like a time scope, like a sliding window of the events that will occur on the rail infrastructure. So, first thing we need, if we're going to go through this, checking whether the plan is operational and operable and safe. Sorry about that. We're going to need to know the plan. What time scope is this plan? Is this like a year? When you have the plan, you also know which rail infrastructure is going to be used. I mean, the rail infrastructure outside is changing continuously. And so this plan pins it on a specific version of that rail infrastructure. And this information is going to be needed if we're going to simulate where the train will be. Now, next part will be then, of course, have the planning item, the train, or it could also be bridge or maintenance, but we'll offer that to Ignite, and from there start our actual calculations. For the train, this will be calculating, taking the signals into account, and this green wave and everything, and just calculating which part of the track will be occupied. Of course, this would be then the second step, where we typically use like Ignite callables, even a cache loader to load the infrastructure. For the actual planning data, we didn't use cache loaders. We used loosely coupled services, basically because plannings can change over time. And you need to know the plan. We could easily load it from the database, but then you're tightly coupled, and the database, the plans which are in there are subject to change, the structural change, and you don't want to be dependent on that part. So these plan items will be communicated through HTTPS, saved in Ignite, and then the calculations start. We started out fairly easy because the demand was we had to, each change the planner makes, we have to calculate it and give feedback within 10 seconds. So our initial goal was take a train, take a planned item, calculate it, and put another one in, and see if there's any conflicts. At the bottom, you see that we, for instance, then have calculated the occupations, and the next thing we can do, we have a data grid completely filled with all these track occupations, and then we can compare them. We can see is this train at the same time on the same piece of track, and isn't this like a newer version of the old one? And well, for the planner, it's really nice to have this detailed view, although there's a lot of movement going on the railways. So for the user to actually get a nice detailed view of what's happening, we aggregate all these conflicts. For instance, if it's a long track where nothing is happening, we'll just put it all together, stating on this track at that point in time, trains are maybe even too close to one another, or they operate on the wrong side of the track, which is also one of the detection algorithms already in place. So a planner changes the plan and should get this supporting feedback, whether it's operable and safe within 10 seconds. This is basically a requirement. And when we upgrade our software, or if a new planning needs to be loaded, the other demand was that we could load an entire plan with all these movements and calculate it within 30 minutes, which is quite fast. I mean, this is like, to give you an idea on the data, these are 10 plans with up to 50,000 movements within one plan. And if you're going to calculate it, this would be like tens of millions of occupations per plan, which in worst case, if it was a poor plan, and well, for the people who are familiar with the cup theory about partitioning, If you have a lousy partitioning in your data grid, this would yield to like billions of comparisons in the worst case. So this is really a challenge, 30 minutes. From a business point of view, it was also important that we would detect every potential hazardous situation. None should be left out, so no false negatives. Rather a false positive, although if you have such detailed info, the information overload can be huge. So preferably the false positive should not exceed 20%. So this was basically the case we got. And as I mentioned, the domain specialist thought of a model really simulating where the train will be with some planning rules applied to it. And this would require actually a very detailed level of the rail infrastructure in the Netherlands, which is also a bit of a challenge because these are construction companies which are mostly concerned about getting their job done instead of describing what they've actually done. So these were both challenges to make this new detection algorithm a success. And of course, having tackled all these challenges, the computational grid should eventually be consistent and complete. Nothing should be left out, or if for some case calculations could not be performed, which could be missing infra or anything, it should be clear as well. Now, I already mentioned like 10 plans, which are then the ones at 1 o'clock. That's right. And these occupations, 10 millions, comparisons, close to billions. And hopefully by the end, I mean, we started out this adventure, we would have less than 15,000 hazardous situations in the plan, to give you an idea how often this might occur. Quite a challenging thing. Now, I picked Apache Ignite for the computational grid. There were some alternatives. I could also do an event-driven architecture. Basically, every new planning item would be an event and would be calculated more like an actor programming style. But for a future point of view, it's very interesting to have such a data grid with all that data in there. You could derive all kinds of new stuff from it, which I'll get to later on. But as I mentioned, we start with the plan, then calculate the occupation, check if there's any overlap, and give the feedback to the planner. And a little bit of detail about what we used in Ignite on this. As I mentioned, the Ignite callables and the cache loaders were basically used to calculate the actual occupations. These were stored using an affinity key because we had so many data. If you want to check these overlaps, we don't want to query every node. We don't want to do the comparisons on every node. The less nodes we use, the more comparisons we can do, or more planning items we can process at that time. So for the occupations, we actually grouped them in a cache per plan. And for the actual track sections that will be occupied, these were also stored with an affinity key, such that we, if we want to determine the overlap, we could do a map reduce. Actually, a compute task, I believe, and really go to those nodes where the real infra of interest is present. Now, this was a bit hard because usually if you have a movement across the rail infrastructure, you're going to hit a lot of those tracks, and you want to calculate it for one movement. So if you're going to do a map reduce, you have to query multiple nodes, each that is touched by this new planning. And of course, in Ignite, you have this affinity run capability. But in this case, we would have a lot of affinity keys. So what we did with the overlap, we did a map reduce. We used Ignite's mapping strategy, its internal strategy to determine which nodes we should query. And once we've done the comparison, found the overlap, we actually also again asserted, are these still the nodes we should have been querying? Is a node data moved in the meanwhile, just to be complete? So we use the MapReduce for detecting the overlaps, the potential hazardous situations, and we store them as well. Because for the aggregations, then we're getting close to the result that a planner wants to see, and we need that detailed information to provide the details to the planner when if something occurred, basically aggregating it to a more readable instruction for the planner. And this is basically how we done it. Of course, as I mentioned from the requirements, we need to load initial plans and we need to calculate any changes that happen afterwards on the plan. So we applied some strategies from big data on this. In big data, you usually have like a slow lane and a fast lane. Now, when loading plans, we want to first initially load the plan, detect all the hazardous situations, and once we have a clear picture of that set, we'll set it open for planning. This has multiple ideas behind it, which I come later on. But the initial loading, this means like normally we have 400 planners which provide a new planning item, while when loading a plan, it's like having thousands of planners inputting new planning. So this is a serious load, and we didn't want to overload the Ignite computational grid. So how do we solve it? Basically with a slow lane, and we used Ignite's service grid for this. We basically queued new planned items into a queue, and each node had like a number of services which take items from that queue and calculate it in the speed that was the cluster was deemed to be able to cope with. For the planners itself, when the plan was free for planning, basically all hazardous situation has been determined up to then. We had the fast lane. Basically, a new planning item or a change gets calculated immediately. We weren't really worried that this would overload the grid because there's 400 planners. We could easily manage that. Additionally, to controlling this load, we used the node attributes for each cluster node, basically being able to enable features of nodes for particular calculations. We could, for instance, if we would have liked to, reserve a part of the cluster, part of the grid for loading, and then for loading of trains, while we use another part for detecting potential hazardous situation or deal with bridges or these kinds of things. To control the load as well, I mean, if you have all this data, you might want to do stuff with it. You want to query it, show it to planners. There's a lot of interesting data in there, so we currently do not have it, but if we want to data mine this data, we were thinking about considering to use the near caches of Ignite, such that you have a copy elsewhere on another other node, and if a lot of queries executed there, it would not harm your computational grid and the loading that was going on there. Same as for controlling that load when you load an initial plan. By controlling the amount of services, you controlled the computational power reserved for loading, basically leaving all the other capacity available for planners. Now, there was one thing, and this is basically the reason why I didn't choose an event-driven architecture for this purpose. If you load a plan, you want to know when it's complete. And in event-driven architectures, you typically have either orchestrated event flow or an unorchestrated event flow. Unorchestrated would be that, for instance, you submit a plan items and the grid becomes active, does all its stuff, and it's done when it's done. While for our case, going through that round, it could very well be that after you've calculated the occupations and you've determined that there's no overlap, the calculation stops. Could very well be that there were overlaps, so that there are hazardous situation, and then the computation doesn't stop. So knowing whether you've detected all potential hazardous situations of all planning items that were present, we needed some ways of determining when is the calculation complete. And with an unorchestrated event architecture, you wouldn't. The only thing you could do is maybe introduce a state machine, but then you have to interact with all kinds of other systems, basically moving towards a solution which Ignite already provides. And that's basically what I've done with Ignite. Because orchestrated events would make it even worse, then I'm back to an entire grid again. So what did we do to determine whether the calculations are complete and consistent? We've applied two mechanisms. Basically a state on the plan. Is a plan loading? Is it calculating? Is it free for updates? And for each planned item, we also had a state. So a planned item, which is actually versioned, can be loaded, also calculated, and can be done. And for each plan item, we registered this basically with the whole plan. And with respect to plan, you could actually see from the state where the computations are. This was how we controlled the grid to be certain that we are complete. And we could also cater for change. I mean, knowing from a plan which state each planning item has, you can easily determine which part of the plan is still in calculation and which plan is already done. And if it's already done, you can data mine the overlaps you found and deliver those aggregates to the planner. The state handling, Ignite provides a very nice mechanism, either using cache entry processes, which allows you to change the cache value in an atomic manner. And of course, you have the atomic references in Ignite, which also are really nice to use, although you don't want to have a lot of them. This we've experienced. And that's basically how we controlled this, using a state model effect. So we have like this giant beast doing a load of calculations, and the planning system could verify with Ignite whether the calculations are done or not. And if they're done, we could deliver the conflicts to the planner. Now, as I mentioned, we used Ignite for this, which was really nice. But this was an organization with a planning system which has been around for like 15 years. And the load required from these servers basically forced them to use bare metal. For Apache Ignite, I didn't want to do this. We didn't know how much load we're going to have, how much resources it required to take, and the configuration of a lot of nodes could be a bit of a fuss. So we've introduced some other technologies to get this all in a nice CI/CD flow. As you can see, these are the technologies we ended up using. At the bottom, the platform upon which we've operated Ignite in pods. So this was OpenShift, and we did our delivery with Ansible. our security with Keycloak, our configurations were managed with Spring Cloud config. We did the contract stuff as well. And of course, monitoring. Because especially if you start out, we had this affinity key on a regional affinity key using the small segments in which we could detect whether there was an overlap or not. And we didn't know if this how our partition hit ratio would be. You want, as I mentioned earlier, you don't want to query all the nodes for a single movement. So we needed to measure how the grid is being utilized and if we were efficient. So with monitoring with Prometheus and Grafana for the dashboards, we got a lot of insight on what Ignite was doing. When it comes to the cluster node itself, we use OPADK for obvious licensing reasons. We've run Apache in using Spring with Spring Boot, which allowed us a little bit of monitoring, nice packaging, all the stuff available that we needed. And we used Micrometer for the additional metrics we required, and of course Ignite. And for testing, I've listed a few of the technologies we've used. Cucumber for the functional testing and Gatling for the performance testing. We've used some other tooling as well, but these were actually the nicest ones when it came down to benchmarking and functional proof that you're complete. We didn't use the framework provided by Ignite because we weren't really interested in whether the cache was fast. Ignite is fast. We were more interested in can we handle the entire load? How would that go? So now I think it's operable for a year now, and we've seen that load. And we also seen, I have the feedback from the planners. And this was interesting because if you have such a detailed view of what's going on the rail infra, or at least how it's planned, this is like a huge mirror for a planner and also for the domain specialists on how well your planning model works, and also with such a fine-grained solution, you might make you aware of stuff which the current planning system might not cater in solving for the planner, may be a bit unclear. So at that point, it was really useful information that came out of the grid to, on one hand, assess your planning model, on the other hand, see how the railways are occupied and where in real life you just need more rails or some other solution to cater for the demand. And another really benefit of this solution was that you get a really clear view of the infra where things is lacking. So it provided a lot of insight, although there were some difficulties as well. As I mentioned, we first started calculating only on a single planned item because we needed to do that for the change. But calculating through all the planned items one by one in parallel, if you're loading an entire plan, this might be hard. Maybe you should provide another strategy for that, one that's quicker, because you don't want to do all the comparisons over and over again. So we started out with just one planning item, really making the problem easy to grasp. Just one planning item, comparing it to the world. But when you initially load a plan, we've seen that this, especially with the more detailed plans, which are close to execution, the performance were not met. We couldn't calculate it within a half hour. So at this point, we are still considering, or actually the team is considering, I'm not there due to European regulations, but they've done a really good job and they know how to go forward. They could try now a different loading strategy to handle the calculations more involved. Another thing that we're considering is enabling the indexing feature, such that basically when you do the map reduce on the local node, we've seen that if you go through like 1,000,000 or occupations, it's really hard to get the occupations of interest on a local node. If you apply indexing, it might be that we can get those occupations of interest faster. So this is a consideration. If you guys have any ideas later on, please let us know. Another strategy I was thinking about is that now we do have the monitoring. We do know a lot about the computations going on, so maybe we can divide the data in the grid as such that it caters communication well. Calculations well. Now it's all organized that each node has the same amount of data, but it doesn't cope for the amount of calculations being done on the node. If you have monitoring metrics, you can maybe using the unsupervised learning strategy to determine a better partitioning strategy, such that the node partition hit ratio is lower for each calculation. So these are still the things considering, although at this point it was already very valuable to have this detailed simulation and plan, and it's definitely improved the plans currently being made. Now for the future, as I already mentioned, having all these occupations allows you for the future maybe even calculate occupation rates. See, for instance, I mentioned Schiphol Airport. There's a piece of track where there are 15 trains passing by an hour. Now we can have really detailed views up till the switches to see how densely occupied a track is, and maybe decide to put in additional track. There's also another product within this company to experiment on this, simulate it, such that you can do this prognosis on the infra demand. But this information can be very useful as well, and our planners have really nice screens to show how occupied a region is, which movements are going through, or actually which, from another point of view, which tracks are crowded by which train and when. And we can add this information to those views, giving an even more clearer picture on what's going on in that plan that the planners created. So this is all the opportunities for the future. Might be interesting also to do some predictive maintenance. If you know how much the train is being occupied, you also know, or maybe you could do some predictive maintenance on that. So this might be interesting for the future, maybe even with the learning algorithms which Ignite supports. At the time when I was on this project, this was still under construction in Ignite, but actually really interested in trying that one out as well. And could even, given the plans, they plan 2 years and a half, get a prognosis on occupations rates for the future. So this is basically what we done. So I hope this was informative, interesting. I didn't hear any questions. If anybody has a question, please ask.
Oh, thank you, Pim. And we have a question in the chat. It was about, was it Ignite or Grid Gain? As I can say, it was Apache Ignite, the open source version.
Yes, we used Apache Ignite. We already had it within another planning solution. And first we had Grid Gain there with all the supporting tools, which was really nice. But this already gave us quite some trust that we could easily do this with Apache Ignite.
By the tools, you mean something like Control Center or WebVisor?
Visor is also in Ignite, but yeah.
Okay, thank you. So guys, you can just unmute yourself or type in a chat. Aha, I see now one question. Please let me know what kind of data do you store in the data grid? How do you export it out of the existing planning system?
Yeah, well, as I mentioned, these are all communicated through HTTP such that we are backwards compatible, loosely coupled when it comes to the planning data. So the planning data is all submitted with JSON messages. The infra data, the details of which switches, which signals, which green wave configuration is there. This was all with cache loaders, so directly with JDBC on an Oracle database. If you look at the grid, we basically stored the meta information about the plan, which was replicated. We stored the occupations, which was with backups and with affinity key. Same goes for the overlaps, detecting the overlaps. This was also stored in caches with a few backups to cater partition tolerance and an affinity key, such that we can easily get to the data we needed. And the aggregations, it's been a while. I believe those were also with an affinity key, such that, for instance, a planner typically looks at a region to have a look at what's going on there. And grouping this data on the regional level is basically the demand for the planner. So this is catering for the queries to come.
Thank you. Do you use Ignite indexing to accelerate calculations? Some tests with indexing did show improvements.
Oh, sorry, I missed out. Could you repeat it?
Do you use Ignite indexing to accelerate calculations?
Yeah, we're thinking about that. As we noticed that we currently used, for instance, for the comparison, a squen query locally on the nodes, and we noticed that if there are 2 million occupations in the cache, this took like 1 second. Now we had to deliver the feedback within 10 seconds, so 1 second was actually fine for a planning mutation. But when we load an entire plan, these 1 seconds, especially if your partition hit ratio is poor, these really add up. So for this particular case, loading a plan, we, as I mentioned earlier, either we could change the loading strategy, it's covered by statuses, or apply indexing such that on the node itself with the map reduce, we could easily list out the occupations of interest using the index. But we haven't done that yet.
Thank you. So, what were the competitors for Apache Ignite when you were doing the choosing?
Actually, I've also looked at, for instance, Hazelcast, but I was really charmed about, for instance, the service grid with Ignite and the artificial intelligence that was being added at that time. I saw this. I saw that as an opportunity for the future. So this really made me decide to use Ignite. These features. If you look at really different products, the actor model would have been interesting. For instance, if you have an actor that's like this little piece of track that's being occupied, you could, for instance, use Akka and then have an actor solely responsible for that piece of track and do all the logic, apply all the logics there. Although there were some risks if you're going to do so, and also miss out on a few opportunities if you want to data mine the data grid for all different viewpoints. With all these, then you would have to go by all these actors to get those viewpoints, which makes it less opportune.
You. Do you use Ignite persistence or external storage? And how many Ignite nodes are used in a production cluster?
Interesting. No, we didn't use persistence. For the cache loaders, we, for instance, applied for the infra to get the infra inside the grid. This was read only. The infra is carefully loaded and supervised, doesn't change much, so we could easily load it from the database every time we needed it. So no persistence there. What was the other part of the question?
How many Ignite nodes are used in production?
Well, we're still figuring out this one. I estimated for all the plans, the 2-year plans, the weekly plans, that this might be 30 nodes. Of course, there's an upper limit in Ignite. Partitioning key is 224 or so, but I don't want to run that many nodes. I think it will take a long time for them to get up and running together. But I expected it to be about 30 nodes. And of course, we can scale up to 1,000, which we don't want to. So far, we've seen, for instance, for the 2 years plans, we loaded like 2,000 movements with 10 nodes, and the calculations were done within a minute. But if you have this big plan, typically having the movements of 3 months, especially with the loading, it took an awful long time. So we really still need to improve there.
Thank you. Any other questions? Are you doing okay on OpenGDDK?
Yeah.
So no problems here.
No problems. What we did have, and maybe that's improved now, because we were, when I was with the project, we were on Ignite 2.7, I think. We had a bit of an issue combining Spring and Ignite. I mean, Ignite has its own initialization phase, and Spring has its context initialization phase, and they don't go well together. I really liked Spring for the configuration part of the cluster, but I did notice that the auto wiring capability is a bit of a nag in this setup.
How large are the nodes and how much memory do they use?
We limited, I'm not quite sure what it is actually today, but we didn't want nodes to exceed 15 gigabyte. Basically, because if we, in the past, they had to deal with these enterprise servers, some dumps to analyze what was going wrong, and this was still a bit of a pain for the organization. So every Java application, the JVM, should not exceed the 16 gigabytes, such that you can at least get the dump in some time.
And next question, what's the Java version used?
I believe at that time Ignite was compatible with 1.9. So we used OpenGDK 1.9 and Spring Boot 2, I believe it was.
Is it possible to see a code of the system on GitHub or somewhere?
No.
So yeah, that was commercial one. Sorry, Max.
It's okay.
So any other questions? So while you are thinking about our questions, I can say what we have in our schedule next 2 meetups already, and that will be fun. So don't forget to look sometimes at our meetup group. Next meetup will be on March 2. And that will be about creating apps for Jira. So cloud app using Apache Ignite. That will be fun. And also we will have a big Apache Ignite event in May. And we hope to see Pim here on one of our discussion panels. So keep reading the mailing lists. The announcement will come soon. Any monitoring tools to view inside the data grid? our next question.
Oh, interesting. I don't know where Apache is at this point because as I'm a solution architect, I always look at what my customer needs and try to find the right technology to match it. So I haven't been doing with Ignite, anything with Ignite the past year. Although I was really interested, maybe for instance, for this geographical partitioning with the affinity key to maybe measure the calculations on that level, applying a weight or creating some sort of a graph which you can put in, for instance, the k-means algorithm to see if you have like 30 nodes, which sections have a stronger relationship to one another, which railway parts and which don't, such that you can create small islands and divide the data in such a way that it's efficient from a computational point of view.
And the next question is really interesting. Which features of the next Apache Ignite version are you waiting for? I guess that's 3.0 you are talking about. Yeah, Max? Did I understand
Could
correct?
be.
So, or maybe next like 2.10. So do you expect some new features or some improvements you would like to see in next Apache Ignite?
Well, I was already thrilled with the product as I met it a few years ago. I really like the service grid with the slow, it's allowed me to have the slow lane. I think all features were basically present. The bit of a nag was what I mentioned with the map reduce. You can have an affinity run or to really get the guarantee that your runnable will be executed on the right node. In our case, this was not enough. We would like to supply a whole bunch of keys and be sure that the data is not moved in the meanwhile. Although I must say, the internals of Ignite were actually the load balancing there, the strategy. These functions you could easily be used. And of course, if you detect that the data has been moved meanwhile, you had to do the calculations partially all over again. But this was actually okay. I mean, how often would that occur? Regarding to Spring, we had to Ignite has these really nice configuration classes for everything. And we basically created our own extension to link it with the auto configuration property stuff of Spring. This was for some parts, this was a bit of hard. For instance, for memory management, these proxies don't work very nicely in the code. But I think that's due to your linking to the hardware that you can't do that in a different way. I mean, we solved it. We put it in a separate library and everything, such that we can use it everywhere. So we had to do a little bit of boilerplating to make stuff easy for us, but it wasn't that it was really complex and a lot of work.
And speaking about the recording, we will put the recording online, and I'll share the link first on the page of this event on meetup.com, and of course on mailing list.
Nice. If there's no questions, I hope.
No, we have a question. We have a question about SQL. That's our hot topic. Any tools to figure out how the SQL optimizer is laying out the plan of execution? So what can we tune if needed?
I don't think I'm familiar with this part.
Mm-hmm.
We haven't applied indexing yet, and exposing the infra data through the cache loaders. This was actually going really fine. Good performance there. If we were to enable the indexing feature, I haven't done it yet, so I don't know if this is going to be hard. Of course, this will be SQL queries on a local node. They're not going to the entire grid. because then this would mean that we, for instance, get like millions of occupations towards one node, and we have to go through that. Doesn't sound like a very nice solution. So it would be local nodes. Surely it will be faster than a predicate.
Mm-hmm. Guys, what do you mean? Explain select, explain via web console. So Ilya, or can you unmute and explain? What do we have here?
I was just answering the previous question. Please disregard.
And what were some major issues you had with Ignite? Any quirks?
Well, initially we overloaded the grid a few times, and for those who've been working with Ignite for a longer time, you get like a strike pool exception or any kind of thing, and it's not very descriptive. It doesn't tell you very much what's going wrong. So I really try to control the situation using the workers and the state machines to avoid that you would get timeouts, because if a timeout occurs, your computations will not be completed, and so the same goes for your result. Your result won't be complete either. We would have all kinds of planning items which will end up in an error state because, we got a timeout somewhere. So this was a tricky part at the beginning. Also, concurrency, the parallelism in such a computational grid. I do not consider it to be hard, but of course, having stuff going loose simultaneously can, if you don't do it properly, it can yield to really awkward results and awkward problems. So this was a bit of a mindset that, especially for the teams, was something new. On the other hand, developing such an engine to actually detect these potential hazardous situations, it's like a little animal that you teach a trick and you put the load on it and see it operating, which is really nice.
And we have a question. Are there other teams in the company using Apache Ignite, and how?
Yes, Apache Ignite has been used in 3 applications. One I'm not quite familiar with because this was part of another product which was just delivered as a service. But the other 2, well, of course, this project, and the other project was detecting also conflicts, but then regarding to plant material, wagons, trains, and everything. There they used a little different approach to how to load and calculate everything. They initially loaded the entire plan. This is not just per plan item, but the entire bulk, which is close to a gigabyte. This had some marshalling issues and some memory issues. So the fact that we've done it with small items at first minimized that we didn't have that risk. Although the computation to load an entire plan, that takes a bit too long still. But these were the only 2 applications we had with and then the supplied product within the company, and basically focusing on computational grids.
Mm-hmm. And we have another question. Do you reboot the cluster for maintenance? I assume it would need at startup time for loading data again, or these nodes are recycled at one time, so that everything goes down at the same time.
Yeah, at this point, after I left, they added backups to the system, such that if one node goes down or a few nodes go down, the system still remains partition tolerant, all data is still there. And this worked really nice. As I understood, they could easily drop part of the cluster, restart a new version of it, although you must be aware, of course, in Apache Ignite, everything is tightly coupled. We didn't enable the on-the-fly cache loading, class loading strategy. We actually package the product with all its classes at once, and that's what came to life. And I believe Grid typically started somewhere being operational and all connected 5 to 15 seconds.
Have version upgrades been easy? So did you change the versions?
I think we started out with 2.6 a few years ago. Did an upgrade to 2.7. There weren't really huge issues, although for Spring it's a bit of a tough cookie. Spring, for instance, if you use Spring Boot, you can get like a master set of versions, parent, and you get all the versions from Spring, which not necessarily is the same version that Ignite is compatible with or your test tooling is compatible with. So especially on this whole dependency mediation problem, when you include software from several parties, which all again use, for instance, Spring, this was sometimes a bit of a puzzle. To cater this, we've had a continuous integration flow in our pipelines, like a separate branch, which at first would automatically update versions of libraries we use within the company. And if that's under control, we could even go as far as that we would always go to the latest and greatest of Spring and Ignite. Although you could wonder why you would need such a thing. Within the company, it was for the internal libraries being developed, it was nice to have such a feature. For the externals, the third-party libraries, you would like to have a little bit more control over this. So basically, within this branch, you could change a version, or it would be automatically changed. A full build and integration and test phase is executed, and if everything works well, it's automatically merged to develop. If it doesn't go well, a flag pops up, and then you know that you're gonna need to plan some maintenance in some next sprint.
So were there many flags last time, or?
I haven't counted them.
I mean, how do you evaluate it? Like smooth, or needed some work, or hard?
Well, actually, we used Gradle as a build tool, and we used their Gradle 5 something dependency management and dependency locking strategy that they provide. But this was fairly new, and actually, I'm an architect. I don't develop that much anymore. Nowadays, I did notice, and some friends of mine also noticed, there are really nice bots nowadays that can actually do this for you. You don't have to do your own Gradle scripting for this continuous integration part. And why I'm mentioning this, so we did this on a separate branch, and this is sort of like a Git flow strategy. If it succeeds, there's a pull request and it's merged. But if it doesn't succeed, you have to decide where you're going to fix the problem. Is the problem something you need to fix in another library? Is it a problem you have to fix in your own software? So you really have to assess what integration issue do I have and where do I need to fix it, and how should the pull requests go on from there. So this was maybe the drawback of the solution of it.
Thank you very much for today's presentation and for the train travel.
Yeah, you're welcome. I really enjoyed doing it, and nice that you all joined.